Hello everyone. Today we are going to talk about sampling distribution, which is a very important concept in inferential statistics. We can say that it is the fundamental concept in inferential statistics. So let's get started. Say we want to look at the heights in centimeter of all high school students who live in city A. That is what we want to know. So this has become our population. Since it is height in centimeter, which is numeric, we can calculate its mean and standard deviation, sigma. So this mean and standard deviation is coming from population. So this is known as parameter. Now, in city A, we have 5 schools. Okay, school 1, school 2, school 3, school 4, and school 5. Each school is a sample, and we can also calculate its mean, small x, because it's sample mean, and its standard deviation. Same goes here, standard deviation. Okay. Now for school number 1, mean and standard deviations are say 180 and 15 standard deviation. Now for school number 2, 178, around standard deviation around 33. Now 190, pretty tall, and standard deviation 100, standard deviation around say 18. And now we got school number 4 around 185, standard deviation 25, say 179, standard deviation 20. Okay, so you can see that each sample has its means and standard deviation, which is known as the statistics. Okay, so here's an important concept. If mean and standard deviation are coming from population, these are called the parameter. If they are coming from samples, they are called statistics. Now for each sample, you can see that its means and standard deviations are quite different from other samples. This is called the sampling variation, because there is a difference in each sample, sampling variation. Okay, so what we are going to do is say the population's means is around 180. Okay, this is the population mean. So we are going to create a distribution based on the sample statistics. Okay, so this is 180, say this is 175, this is 185, this is 190. Okay, so we got 181, say got 178 around here, 1. Now 191 and 185 here, 1, and 179, so around here. So this is the distribution, sampling distribution. So you can now see that if we have to create a line curve, this line curve will look like this. This is the tail is on the right side, so it is the right-sided right skew distribution. Okay, so what have we learned so far? This is sampling distribution because this use the statistics of sample and look at its distribution. So what is important about this sampling distribution? So based on the sampling distribution, what we have come to know is for the population mean approximated by sample mean, and for the population standard deviation is approximated sigma is approximated by standard deviation square root of n, sample size. N is sample size. Okay, so this concept is basically called the central limit theorem, which is a very important concept in information statistics. Okay, so what central limit theorem says is that regardless of the population's distribution, either is normal or is not normal, if the n sample size is large enough, and then we got the sample distribution is tend to be normal, approximated to be normal. So this is basically central limit theorem. Okay, so that is the gist of central limit theorem, but there is two requirements in order for us to use central limit theorem. Requirements. Number one, each observation has to be independent. So we call this is independent assumption. Number two, sample size has to be large or sufficiently large, not necessarily large. So as a rule of thumb, n should be more than 50 so that we can use central limit theorem.